Hi there, this is Tyler Taldone, and I'm about to demo Lab 2, in which I can make this circuit turn from blue to purple to red based on thermal conductivity, and we are here in the beautiful ELEC 327 room where people are still hard at work and getting their codes working, and I've calibrated it so it works in here based on the room temperature. So let's go through this code. First of all, we stop the watch start timer, then we're going to want to set up the pins for the red and the blue LED, red corresponding to pin 2.1, blue corresponding to pin 2.5. Next thing we're going to be able to do is set up the timers for the clocks. And we make the register 0 of timer A1 interrupt enabled first, and then we're going to set TA1 CCR0 to 1023, which corresponds to the maximum number of samples by the ADC converter. Next we're going to have TA1 CCR1 be half of that, because that's like in the middle of the spectrum. TA1 CCR2 be a half of that as well for the same reason. Next we're going to alter timer A1's clock by making it go to small clock, put it into up mode, and then we're going to also put the control register 1 of the timer into output mode 7, which is reset set for both of those registers. We're also going to then deal with the ADC 10 and enable it, enable the interrupt for it, and make it sample less frequently, sample and hold more frequently, and turn on the reference generator. Then we're going to make sure that our voltage only goes from 0 to 1.5 rather than 0 to 2.5, and enable the thermistor at pin 1.0. And then before we go into our interrupts, we are going to enter low power mode 0, which allows this clock to stay on but turns off most of the other ones. Next we're going to look at our first interrupt, which deals with the ADC10 mem vals. So first we're going to create a variable mem value which reads off the ADC10 mem, and then I'm going to create upper and lower bounds that were based off of calibration from recording the ADC10 mem vals at room temperature, and then like when my fingers are pressing against it very hard. And so we also have this little formula down here which sets the blue ratio for the ADC10 mem val of the thermistor, and then also the red value. And that's the interrupt for the ADC10, and then we're going to also have the timer interrupt, which enables and starts the ADC10 conversion. So next I'd like to demo to you guys the circuit that I built, and as you can see on the launchpad, the MSP430 is not there. All we have are some jumper cables leading from ground, from VCC, and from set and test and reset to the very dense small board that was provided. MSP430 has been put in there and has been unplugged so that you can see the intricacy of the circuit. It's powered by VCC and ground wires. The thermistor, which is right here, is connecting VCC to pin 1.0, where we configured it using inch. This is a capacitor to make sure that the values come out clean. This is a resistor of similar resistance that is going to connect P1.0 to ground. And we also have for the LED, this LED, that we have the red LED portion connected from P2.1, and then we also have the blue LED portion connected to 2.5. And it all fit on this nice small breadboard. Okay. So now I'm going to demo the mood ring in action. I am going to program it. So we'll wait for that to happen. Now I'm going to press play. And you can see that it's a very nice blue LED right now, meaning that it's at room temperature, that nothing has come into contact with the thermistor. But if I put my fingers on the thermistor, it should change from blue to a very nice red, and then when I release, it should turn back to blue. Awesome little mood ring, pretty cool circuitry. Had fun.